video is on the classification of matter. So in chemistry, we study the composition, structure, and properties of matter. But what is matter? Well, matter is anything that has mass and takes up space. So it can be classified into two major categories. Matter can either be a pure substance or it can be a mixture. A pure substance is something that is either an element or a compound. An element is where there's one type of particle. So you might just have copper, you might just have aluminum, you might just have helium or carbon, but they're just one type of particle there. A compound is where we have a combination of elements. So let's say we have hydrogen and oxygen, they make water. Or we can have carbon, hydrogen, and oxygen put together to make sugar. We're putting together different pure substances or elements, and we're making a compound out of them. Instead of a pure substance, we can have a mixture. So this is a combination of different substances, so different compounds or elements, all mixed together, but not physically or chemically bound together. So a mixture can either be homogeneous or heterogeneous. Homogeneous means it's uniform in composition, such as vanilla ice cream, whereas heterogeneous is non-uniform in composition. So that would be chocolate chip ice cream. So you'd see the chocolate chips in the ice cream. You can see the chocolate chips and the ice cream are two different things mixed together, and you can still see each one. Whereas vanilla ice cream, we can't see the differences, the milk, the sugar, the vanilla. We can't see them in our substance, so we consider that homogeneous. It's uniform throughout. Within matter, it can take three different forms. We can have solid, liquid, or gas. Our particles are going to spread out as it goes from solid, liquid, to gas, except for water. So in a solid, it's going to be bound very tightly together. Our particles are going to have strong attractive forces. Their shape is going to be definite, so if it looked in the shape of a cube, it's going to stay that shape. And its volume is also going to be definite. You can't alter the volume of the cube. A liquid, however, the particles are spaced a little further out. They're fluid, they can move past each other. The attractive forces are moderate, so they're still kind of attracted to each other a little bit, but they can still move. Their shape is considered indefinite. It means that it takes the shape of its container. So if I pour a liquid into a glass, it's going to go ahead and get rounded like the edges of my glass, whereas my solid would stay as that cube. And then its volume, well, its volume is definite. You can't change the volume. So we say that it has definite volume. This is different than a gas. A gas has the particles spread out as far as possible. They zoom past each other. They are not attracted to each other at all. Their shape is indefinite. It again takes the shape of the container. I can't confine the shape of my gas. And its volume is indefinite. The volume of my gas is going to fill a container. So if I blow air into a container, the air is going to take up and move around to fill all the spaces of the container. It's going to bounce all around. It's not going to be confined like a liquid is, keeping the volume that it was given. So the volume of a gas fills the container. So we have different types of matter. They can take different shapes, and we can classify them into different properties. So we have physical properties, which are characteristics observed without changing the substance. We have chemical properties, which are characteristics that are observed when the substance changes in composition. So something like this is we're going to see a change in composition, whereas here, we're not going to change the substance. A physical change, the form and shape change, but the same substance and the same properties. Where a chemical change, the composition changes, but the particles are also rearranged. So here we're making a new substance. Here we still have the same substance. A physical property, we're not changing the substance. Where a chemical property, we are changing its composition. Go ahead and think about some examples you could look at for my different physical and chemical properties and physical and chemical changes. changes, we can have chemical reactions. So a chemical reaction is one or more substances are changed into new substances due to particles being rearranged. So we talked about the elements and the compounds earlier. Those elements and compounds can get rearranged and they can make new substances. There's 5 indicators of a chemical reaction. You want to know these, memorize them. So 5 things that can happen that tell us that something's happening in front of us that's a chemical change. First, a gas is released. We can see this in the form of bubbles. Second, a precipitate might be formed. Precipitate is a scientific way of saying that a solid is made. Now this won't be one big clump. It usually looks like a powdery substance inside of a liquid, but that is your precipitate solid forming. You can also have a color change. Maybe 2 clear colorless liquids are mixed together and they turn yellow. That's a color change. Odor is produced, so maybe you have 2 odorless items and then a smell is made. Or temperature changes, so you might mix 2 things together and it gets hot or feels cold. Now in a chemical reaction, it's always reactants on the left with an arrow and products on the right. So some examples here, A plus B, those are your reactants, make C as your product. You could also have C could decompose into A and B, or you can have 2 compounds come together, rearrange their elements, and make 2 different compounds. But in every one of these cases, the items on the left react, they're your reactants, so they react together, and they make or yield some product. So anything on the right is a product. So reread left to right, same thing with a chemical reaction. It goes from left, your reactants, to your products on the right. So for example, if I have hydrogen plus oxygen, they react together to make hydrogen dioxide. So hydrogen plus oxygen makes H2O.